talk about Spray. First, a little vanity slide. Who am I? I'm developing software for iOS and the web. I studied software engineering and currently work for Create. I'm also responsible for online services like FutureZone, Create, Entitate, whatever. Back to Spray. Who of you has heard of Spray? About half of the people. Who has actually used it? Two.
Okay.
All right.
Who has used it? You too? Okay.
The agenda is structured to talk the way I like it. First, I'll tell you why you should care about what I tell you, and second, I'll show you a bunch of code. First, what is Spray? I stole that from the documentation. Spray is a suite of lightweight Scala libraries providing client and server-side REST HTTP support on top of akka. So let's go through that. Spray is for REST and HTTP support. So it provides you sort of libraries for client and for the server. A lot of people might think that it's only for server-side REST services, but it's also for consuming those. Very important, Spray is a set of libraries. So it's not a framework, so it's like Play. Spray doesn't tell you how to structure the application, it just gives you a bunch of tools for a REST service and to do HTTP transactions. And everything is built on top of akka, which is very awesome for everyone who knows akka, which basically means if you don't know akka, it's mostly asynchronous, fast, and easily scalable. A little bit of history. Spray was started about 3 years ago by a German guy called Matthias Dönitz. Their final versions were just released about a month ago. Final versions because 1.1 targets akka 2.0, 1.1 targets akka 2.1, 1.2 targets akka 2.2, the most recent version. And they were all released simultaneously, but akka 1.2 is the one Spray 1.2 is the one I'll refer to, but this should be more or less the same API-wise. Very important, Spray was acquired by TypeSafe a few months ago, like some of you might know, the company behind the Play framework, akka, and so on. And Spray will move into akka and will become akka HTTP. The timeline for that is that it should be ready for akka 2.4, so 2 versions ahead, and it's said that they want to release it by May or June of next year. So my best guess is that they just will release it at Scala Days in Berlin in June. Which would make sense marketing-wise.
There were also rumors that the Play framework will replace native Play at some point.
Yes. Play will move onto akka. They announced that. So it will happen throughout the next year. I don't know if to replace native fully, but yes, it will move onto akka and akka HTTP. So you will have a more unified stack and hopefully also faster. The future for Spray or akka HTTP, also known as what doesn't Spray support yet. One big thing is WebSockets. But since Play needs those WebSockets, they will have to support those very soon. And also Speedy is a big thing they have to integrate in the near future, and they announced those, so I didn't make this up. They will integrate those very soon. The major components. As I told you, Spray is a set of libraries. Those are the 4 major libraries you will encounter if you work with Spray, but there are also a bunch more. Well, let's go through the 4 major libraries, and we'll also show you code for each and every one of those 4. The first, you see on the right side, is Spray HTTP. This is basically just the data model of HTTP. So you have case classes and everything is type safe. Even the content headers, the response types, the codes, everything is typed. So you can check against those also in your tests. And you can use those alone if you would want to. So there's no dependency to other Spray libraries for Spray HTTP. Then on the bottom, you see SprayCan. SprayCan is a low-level HTTP server and client. So you could use those, but most of the time you would probably use either Spray routing or Spray client, depending what kind of stuff you would do. I'll show you later why that is. Spray client is obviously for client stuff if you want to consume an API or want to talk to another web service. And Spray routing is if you want to build your own REST web service. And Spray provides their own domain-specific language, DSL, for constructing those services. I'll show you that later. Oh yeah, and there's also other stuff. So you don't have to deploy Spray with SprayCan, but you can also deploy it as a servlet. So there's no library for that. If you have to integrate or want to integrate it with the current architecture that might be Java based. There's also test kit and some util stuff. But again, those are the four major components you will encounter if you work with Spring. Briefly, the I/O stack. On the top, there's obviously the application. Then, as said, you will use Spray routing or Spray CAN. Spray CAN will talk to akka I/O. Akka I/O was, by the way, known as Spray I/O before they integrated it in akka I/O. Akka, so it's now known as akka I/O, which was the first project for the Spray and the Akka team to work together. Akka I/O talks to Java new I/O, not that new. And then there's obviously the US level network stack. The last graphics before I'll show you some code is this one. Again, Spray is not a framework, it's a set of libraries. So the way they describe it, it's an HTTP integration layer. So it sits on the side of your current application, and it doesn't integrate with your application directly, and it shouldn't leak into your application. Because Spray takes an HTTP request and then communicates with your application through domain objects. So no HTTP request should go directly into your application, but Spray should be responsible for translating HTTP requests to domain objects to communicate with the application. Then the application communicates back to the Spray layer, and Spray layer then answers with an HTTP response. Any questions so far?
Yeah.
Yep.
How does it happen? That request is translated to domain objects. You have to
provide
some translators, right?
Yes. You can either do it yourself, or there's also JSON marshalling, unmarshalling. I'll show you that later. It's pretty concise and small, so if you provide the right request, it automatically unmarshals it into your domain object, and then you can test it on.
Case class.
Exactly, case classes, and you have to provide a JSON unmarshaller and marshaller.
Okay, thank you.
All right, I apologize for lack of syntax highlighting, but I'll switch to IDEA later, so this is just 2 slides. This is Spray HTTP. Remember, this is just the HTTP model. So for instance, this is the case class for the HTTP request. You see the method, it's get, in that case, by default, and the URI, a list of the HTTP headers that were sent, the entities in the protocol. The response looks similar and I guess familiar. Yep. All right. This is just the domain model you will work with if you work with Spray. So, can you read that? All right, I guess. All right. First, we'll take a look at Spray client. So if you want to consume a web service or just make an HTTP request, I'll make it look. Can you read that? Should I make it bigger?
Maybe you can switch to the normal scheme with white and black. It's better to
Sabrina.
This is already intelligent and certain. Then you have the presentation mode. If you just cancel and then start the action, you make it command, shift R, A, and then say presentation. Double presentation mode.
Ooh, awesome, thank you. Yeah. That's cool. All right, first I want to talk about Spray client. As said, there are a few ways to make an HTTP request. First, we need an actor system, which is basic akka stuff, as a implicit value. And we also need an implicit timeout for some calls. Just ignore those for the moment. The one line you want to look at is the first one here. First, we need an actor reference to send the request to. So we get it by calling akka I/O now and saying we want the basic actor for HTTP. At this point, you could also say TCP or UDP if you would want to do something different, but we want to send an HTTP request. This is the tell pattern. So we want to send an HTTP request, just provide the URI, and say Scala and org, and the sender would get the HTTP response back. But since we're not in an actor here, we're not getting the request back, but that's the stuff you would do if you would be an actor. Again, you could match against an HTTP response. One thing we want to do, and which we'll also test in a second, is this one. We use the akka ask pattern. So instead of an exclamation mark that we saw earlier, we say question mark, which means we get a future there back. This future is unfortunately untyped, so we have to map that to HTTP HTTP response. Just with the standard on complete handler for future, we can complete that response once it's coming back, and we just print it. Let's try it out. This is an important thing. It's just this one. Right, a bunch of stuff happens. I put akka to log level debug, so you get a bunch of stuff here. We want to start it. Previously attempting new connections to Scala and org, which is the request that I just sent. And eventually, blah blah, request comes back. You see here, it's a try, so it's wrapped into success in that case. Here's the HTTP response with 200K, and you saw it just worked. Requested Scala and org, and this is the answer. All right. But there's also another way, which is the one you probably will use, which is through pipelining. Spray provides the send-receive thing. You see up there, it's a function that gets some implicit parameters, which we have to declare up there. And we also get a future back, but in this case the future is already typed. And you could do a lot more with pipelines, so you could actually state if it is compressed or not and what you want to do. But this is the basic thing, and it does exactly the same. So you get a future back and then requests it, and in the block there you can print the response. Actually it did just run, but it more or less provides the same, so let's skip that. Now the spray can. Spray can, as I said earlier, is the low-level HTTP service. If you do a server, it lives inside of an actor. So you have to instantiate an actor here as a value, system actor of props my service can. My service can is an actor. And then I bind it to IO HTTP, that we saw earlier, to localhost 8080. And now let's look at switch.
Yeah.
Right, this is my actor that does the low-level HTTP stuff. So as you see, I actually respond to requests here and match against them with Scala basic matching. So I say, if I receive an HTTP request, then with method get and path Scala, I just reply with Scala and org. If I would get a request with akka, I would reply with akka. If I get an HTTP request that doesn't match to any of the above, I just say on the resource and say status not found. Again, everything is typed here, so you can't say not found. This isn't actually typed in this way. You don't have to try 4 or 4 or anything. So let's try it out. It's 8080. Scala. Here you go. This is Scala and org. I sent this response in IntelliChain. And the same works for akka. Or if you provide something else, it says on the resource and actually also. It's a 404. Everything works out of the box. Right, but For this, you can use, but most likely you will use spray routing, which I'll show you now. Spray routing is the DSL on top of that. The first, I have two services I want to show you. The first one is the basic service that they provide with the template. Let's just start it. It's an actor. It's called My Service Actor, extends actor, and implements the trait My Service. And the whole routing is decoupled from the actor itself, so you can test the trait by itself. And first you need to provide the context as actor red factory, so you could be in tests or in production. And then in the standard receive method for actors, you just say the run route, which comes from spray, and you give it your route. And this is the more interesting part here. This is the actual DSL. So first, for instance here, you specify the path, which is the root path. Then you say you only respond to GET requests. Then in this case, you want to say respond with media type text, HTML, because what you provided the complete handler is XML, so you don't want XML here, but HTML. But that just works, it's very readable, just to the path, GET respond with media type, and complete. And there are a bunch of directives like that I'll show you more later in another actor. Well, let's try it out first. It's actually running. That's it. Say hello, the spray routing on spray can. If it would provide anything else, automatically get a 404 and request resource couldn't be found from spray. So spray handles those cases too, and you don't have to. So let's switch to the second service, which is a little bit more interesting. Let's start here. I have time at the top, so it's /time, not /time, or wherever I bind it. Then I respond to GET and to POST requests here, because the chain where the tilde, that's an operator Spray provides for chaining directives. If you have a GET request, in that case, a directive from parameters, I say it needs a timestamp GET parameter, and it only allows it if it's a long. So if you would, for instance, provide a string, it would fail automatically right here. All you need to do is say you want it to be a long. It gives the right response back, saying, hey, I need a long or a 64-bit integer here. And you can also say you need optional parameters. And you don't need to type them, but you can. And they respond with complete, and in that case I just send back what I got. And for the post case, for time, I compress the response, and if I can, then I complete it with just as a post response. So let's try those two out. Alright, first I'll try. You can see that I just requested /time, and it's telling me request is missing required parameter timestamp. So let's provide timestamp. Just provide the timestamp ASDF, and it tells me it's not valid because it needs to be a long, right? So if I provide something, it says back 1, 2, 3, 4, the timestamp, and none because it didn't provide the second optional query parameter. And if we would provide the 2, then it's a sum because it's a try. So it's right. Then the second thing, secret. You can also say have authenticate directives right there. In that case, it's just the basic stuff. We have to enter a username and password. But you could also do something more complicated, where maybe an LDAP service is ask for user information and whatnot. So let's try out. It's just alright, so it's asking me for a username and password, which by the way are yep.
Where did you configure that?
Here. Wallace boilerplate. Expect user pass, and as a config factory password.
Yeah, but where do you say that the
Basic off, well, admin area. It also tells me here it's admin area. This side says admin area. The config is the config that you stated here. And the same create users. It's just full boilerplate. All right, then I was allowed to access the variable. The last thing, which refers to the question from before, is marshalling and unmarshalling from objects. So here I have a path bookmarks, and in the case of a GET request, I complete that with a new object that I can create right here. Right up there I have a case class, which is very basic stuff, just an ID integer, name string, and a list of links, all the strings. And what I need to provide is a JSON protocol. So it's a type root JSON format bookmark. And I have to say JSON format free in that case because there's free parameters. So if we would extend the case class with another string, I would have to say JSON format 4. But that's about it, all you need, more or less.
Also limit like 22.
I think it had, but I think they lifted it or something like that. And you can also provide your own unmarshalable. This is just this basic stuff they implemented for all types you would normally encounter, like int, string, or whatever, but you can provide marshals for your own stuff if you want something different that doesn't fit the general use case. So you have that, it's implicit. And if it completes the request just with the new object, it automatically gets marshaled into a JSON. So bookmarks here. Voila. This is the case class, and all I need to do is provide their JSON format. The same works for post requests. Here I have a new directive called entity. And I say the entity I get in my post request has to match bookmark. Entity does bookmark. If it doesn't, it would fail, and it tell me why it fails. To tell me, okay, I'm missing a parameter name. And then you complete it, and in that case, it just send it back. But this is the point where you would usually send it off into the application. So let's look at that. I have my REST client here, which is, let's copy that over so we have the right format. Post, obviously, we'll change something here. That's about it. Says okay, and it sends me in that case the thing back. So if we would remove now the name, for instance, send it off again. And it tells me the request is well formed, but it's missing the parameter name. So we can't unmarshal it, it needs a parameter name. Same would be if it would send the wrong type. If it would send an int here, it would equally fail. The requested string is expected a JSON string, but not free.
Is that configured, or is it because
It matches the case class. Yeah, it's a case class that sees, needs a string to match it to it, and so it fails with the string. JString is a class from Spray, so you would use that if you would unmarshal a string yourself. The last thing I want to take a look at is testing.
One question.
Yeah, of course.
This JSON marshalling as code, where you define it as JSON format suite. Is this a macro or is this?
It's a method here. It's a case class. This is code from Spray now, actually. You see there's JSON format 3, it's JSON format 4, which is, I guess, a lot weird looking at, but it works.
I don't get it how it gets the types out of the case class.
Alright, extract field names. I never looked at the code, so
That's
Okay,
it says
crazy
Here,
stuff,
right?
What, Alex, you don't understand this?
Oh, I understand it, but don't explain it.
It's intuitive.
Switch back.
Und wir machen eine Probe, alle bereit machen, also dann los geht's.
Again, you're pretty much free because you have free parameters. And it's typed automatically and off you go. And it really suffices in most cases, unless you have something super fancy and want to delimit the output and say you only want to give the ID back and not everything, or some special format, some certain type of responses, then you would have to respond, require your own JSON. Anything else at that point?
I have many questions, but do you prefer me to wait until?
No, let's start now.
Now, well, the first question I think would be, why would I use the spray and not, or what is the advantage of using spray and not maybe, sorry if I say this, using Play for implementing web services?
Well, you can, but again, Play is a whole full-blown framework that tells you this is how you need to structure your code.
Okay.
Everything else in Spray is just a set of libraries you can integrate with the current application.
So this gives you more flexibility and it's more
Absolutely.
lightweight.
Yeah,
Okay.
and it provides a second layer as opposed to the whole layer for the whole application where you have to throw everything in as we play.
And you mentioned integrating.
Yeah.
Is it possible to integrate this into a Play application?
I don't see a use case for that, to be honest, because Play has the routing inside, and this is routing and authenticating and unmarshalling. So I guess you could for the unmarshalling stuff, but
I was thinking
yeah.
implementing like REST API in Spray and front end or web-based whatever Play.
I guess you could, because you have your models inside of Play, and then you just use those in Spray.
But it would be possible to use the same port, for example?
What do you mean board?
Port of the Play application. Or would Spray open a port and Play would open another port?
That's basically, yeah, it would open another port, so you would have to
Okay. So
use Nginx in front of it, so automatically so we have it out or whatever.
I have. How much RAM does your machine have?
2 gigs, I think.
No, you're kidding me. Really?
4, sorry.
Okay.
Spray reminds me a little bit of Sinatra or Scalatra.
A little bit, yeah, I get what you mean. But I think it's more powerful as it provides more directives. Everything I showed here is just stuff you need, but it has way more. So if you want to Spray.io, for instance, the documentation is really awesome, by the way, which is not very usual for a Scala project. Good news. Again, you have a lot of directives you can use. So this is everything that comes out of the box. You can also write your own, obviously, but you can, I don't know, respond with status. You can get the IP from a request. Okay, that's the thing. But usually you want to structure it in a right way.
Could I say a list of strings?
Okay, Karl, danke.
Get whatever comes after that.
I'm sure there's some workaround for that. Seems to work. Usually you would have, you can also nest pass. So you could say, I want to have a number here, page number. And then you have multiple directives for path, and like time, awesome, whatever. And then you have a section.
After the number, then
Exactly. So the path then would be time slash 1234 slash awesome. And whatever. My questions?
is there XML support?
This built-in XML support in Scala, actually, so I'm sure it has unmarshalling and stuff like that off the box. I never used it though. Right. Little short look at testing. Again, those are just the tests taken from the spray template, so I didn't write those. But you see how it will work if you start to test your framework, your routes. This just takes the routes, which is why we split up the route of the actor. Right actor factory. Get from my route, check the response as string must contain, say hello from spray can as we just saw earlier. And then you also say you check the get requests to your routes that you didn't define, respond to the 404, are not handled. It's very straightforward. See the route here is only that it doesn't fail with a error.
How much is the overhead for starting these tests?
Weil von hinten ist okay, oder?
I don't know, I never did something really big, so I can't state it, but I'm sure once you actually know the syntax and know how you would structure it.
Does it take a while for the tests to start so that they run?
No, it's actually super fast. So just those tests, so you have to switch back to the actor which uses.
Because in play it's to start like a fake application, it takes a little while.
Not a bad. It's a test, the file's now. I mean, only 3 tests obviously, but it creates an own actor and takes those routes and just tests the routes basically. Alright. That was it actually. So, any more questions?
So if you would build an Angular.js in the front end,
Yeah.
would you use Spray or would you use Play from?
Personally, I would use Spray because Play provides a lot out of the box that you don't need, especially for an Angular application. So you have more separation of concerns than, I guess.
Play also provides a lot of things you would like to have, like require.js support,
Sure, but you could use the
JavaScript dev pipeline.
yeah, you do. Of course, but it's still more separated. You don't have a full-blown framework only for stuff that only happens on the client anyways.
So you would use a JavaScript-based build for the front end, and then the back end. That's what you meant, I think.
Yeah, the tools are better.
For instance, again, you don't really need it. So. But if you know you will use stuff that overrides and Spray doesn't, yes,
Would it be possible or thinkable or recommendable to make a web framework with Spray?
I mean,
No,
this is what will
sorry,
happen, right?
web
Play will
application.
move on to Spray. Or
Sorry, no, web application, like a web page or web application.
Oh, you mean just normal HTML stuff like that? I guess it's possible because it's a Spray can, so you can't do the routing. You can also just do routing with Spray routing. I don't know if you would actually do that. I would use Scalatra, I guess, if it's really simple. So, it can be done. But there's no templating engine out the box.
What do you use it for?
Personally, just APIs or as backend. All right. Thank you. Good interview.